welcome back all the NEET aspirants. A very warm welcome to all of you. So guys, here in this session, what we are going to do in this session, guys, we are going to do some problems on the error analysis, right? So guys, I welcome all of you to your very own channel, NEET Success Simplified, and I am Dr. Shankar Sir, your physics educator, and we are going to do now some questions of error analysis. So in the last session, we have come to the error analysis part. We started seeing that what are the errors, how we can, you know, take care of the errors, right? How can we, add, multiply, divide. So basically, we were talking about the propagation of errors in the last session. Okay, so what is the error in the final calculation when we are adding two quantities having some individual errors, subtracting, multiplying, division, and the last thing what we have done, the last thing what we have done there, the last thing what we have done there was, so this is my brief introduction. So I hope all of you now must have known me, and if you don't, then you can go back to the previous sessions and you can have my introduction there. Okay, okay. So the last thing that we did in the last session, so we were talking about the error propagation. So if the quantities are raised to some power, this was the last thing we discussed in the last session, right? So if the quantities are raised to some power, what is going to be the error in that? So if x is equal to a to the power p, b to the power, let's say, q, and c to the power r, so now a, let's suppose, having some error. Okay, so a is equal to a plus minus delta A. So similarly, b is equal to b plus minus delta b. Okay, and c is equal to c plus minus delta c, where a, b, c are the true values or the actual value or the average mean value, whatever you want to say, you can say it. Okay, okay. Now please understand this. So here, how we were going to take care of the error. So see, A, B, and C. So X is made up from A, B, and C, and they are raised to some power. Okay, like the power to A is P, the power to B is Q, the power to C is R. So certainly they are raised to some power. So X is made up of A, B, and C, and A, B, and C are having some powers to it. Now, in this case, what is going to be the error in the X? What is going to be the error in the X? This is something we are interested in sorting out. We are interested in finding out. So how can we do it? How can we be doing it? So for this, how can we do? So we have to use the principle of differentiation. So lastly, we have seen this. So we can write this way, no? Delta x by x is equal to, so similarly, delta a by a, like the same way we have done for the multiplication and division by using some of the differentiation, delta c by c, and all you have to do, so you have to write p, q, and r. So whatever power is there with whatever quantity, you are going to have it multiplied. Okay, okay. Now see, when you see the question, so language of the question is very important. So sometimes they ask you the fractional error, sometimes they may ask you the percentage error. So delta x by x is what? Delta a by a, delta b by b, delta c by c. So these are fractional error. This is fractional error. This is fractional error in x. Okay, this is fractional error in x. This is fractional error. Fe is what? Fe is the fractional error. So we know the fractional error, right? Okay, we know the fractional error. Okay, okay, we know the fractional error. So what is the fractional error? Fractional error is x, fractional error in A, fractional error in B, right? Similarly, this is fractional error in C, fractional error in C, right? Fractional error in C. So these are the errors in the measurement. So this is the things here. Okay, fractional error in X, fractional error in A, fractional error in B, fractional error in C. So all these fractional error, guys, all these. So I think my voice has some disturbance now. I think it is clear to everyone. Okay. So here the fractional error in X can be sorted out with fractional error A, B, and C. So how to deal with the powers? I hope it is clear to everyone. Now, if in this equation I multiply 100 on both the sides, so delta x by x into 100 is equal to P times delta A by A into 100 plus Q times delta B by B into 100 plus R times delta C by C into 100, right? Okay. So now here, what I can say is that this is straight away percentage error in X. No, this is the percentage error in X, right? This is the percentage error in A, percentage error in A. This is the percentage error in B. So sometimes they right away give you the percentage error. So this is the percentage error in C. So right away they give you this percentage error, okay, rather than giving you the error or fractional error, they right away give you the percentage error and ask you the percentage error in some other quantity. Okay. Now, anyways, I hope you can be able to do it. Now, let's solve some of the questions. Okay. So, see, as I say always, so some concepts are better understood with the help of questions. So, now we are going to do some questions here. Okay. So, let me give you one question now. So, see, with the help of these questions, we are going to be understanding the things in a good context. So, see, here is the first question. So all the live students, okay, or anyone who is watching it after the live session, okay, that is the recorded session if anyone is watching. Okay, so I think this is not completely just a minute. Yeah, seems to be better now. Yeah, now completely visible, right? Now completely visible. Now let's try to do this. Let's try to do this. How we can do this? So it says in an experiment, the percentage of error occurred in the measurement of physical quantities A, B, C, and D are 1%, 2%, 3%, and 4% respectively, then the maximum percentage of error in the measurement of X, where X is equal to A squared B to the power 1 by 2 divided by C to the power 1 by 3 and DQ. Okay. So X is given as A square B to the power 1 by 2 upon C to the power 1 by 3, C to the power 1 by 3 and D to the power 3. Okay. Okay. And for each of this quantity, for each of this, A, B, C, and D, the percentage, their individual percentage error in their measurement, in their respective measurement is there. Okay. So see what we are trying to do. See, this error analysis is a very, very important part in the world of physics, because see, physics, the physical, it is the game of physical quantities. So in the physical quantities, what is physical quantities? Something which can be measured. Now in each and every measurement, there is some error. Okay, so what we have learned, no matter how hard we try, there will always be some error in the measurement. So when A, B, C, and D were measured or would have been measured individually, they would have been measured individually, there they must have some error of themselves. Okay. Now, when they are involved or when they are used to find another quantity, another physical quantity X, obviously their errors are going to propagate to X. Okay. Now, how they are going to propagate, that is what we are going to see now. Okay. So see how we can write. So now, sir, we can use the principle of differentiation we just have come to know. So delta x by x, okay, into 100, and I'll right away write the percent because they are asking you the percentage error, is equal to 2 times delta a by a into 100. Okay, you'll have to do 1 by 2 delta b by b into 100. Okay, okay, plus, see, plus 1 by 3. So it is in division. We must subtract. Nothing. You have to do plus only. You have to do plus only. There's nothing that you have to do there. Okay. You have to follow the same way. So plus 1 by 3 delta c by c into 100. Delta c by c into 100 plus 3 times, plus 3 times delta d by d, plus 3 times delta d by d into 100, plus 3 times delta d by d into 100. So we have to write like this. Okay, we have to write like this. Now see. Now, some student, what do you say? Why we are not cancelling this 100 out? We can cancel this 100 out, but we must not cancel this 100 because see, you are given the percentage error in A, B, and C. So you are given the percentage error. When you are given the percentage error, guys, in A, B, and C and D. Okay, so if you cancel out this 100, then it will no more be the percentage error, right? It will not be anymore the percentage error. So I'll have written, sorry, I just forget that in the screen I am also been there. So I'll just I'll write it here. Okay. Plus 1 by 3 delta c by c into 100. Okay. Plus 3 delta d by d into 100. Right? Okay. This is how it is going to be like. Okay. Okay, so when we are using this concept of propagation of error to the quantities raised to some power, we are going to have it written like this. Right? Agree? No worries, sir. Now, directly they have given you the percentage error of A, B, C, and D. So, how we are going to write it? So, see, delta x by x into 100. Right away, this is the percentage error of x. What is it? It is the percentage error of x. Then 2 times delta A by A. So what is the delta A by A into 100? So this is percentage error to A. Can I write like this? Percentage error of A. Okay. Percentage error of A plus 1 by 2. So this is delta B by E, B into 100. So this is right away percentage error of B. Okay. So in examination, we are not going to do this slowly. Nah? Okay, right now I'm doing it this way because this is where I'm explaining to you. Okay, but it doesn't mean that you also solve in such a speed. Percentage error of C. Okay, okay, and this is 3 delta d by d into 100. So that is percentage error of D. Percentage error of D. So this is the percentage error of X. Percentage error of X is 2 times percentage error of A, half times percentage error of B, 1 by 3rd time percentage error of C, then 3 times percentage error of D. So what is going to be the percentage error of X? So this is going to be 2 into percentage error of A. So what is the percentage error of A? So it is 1% plus 1 by 2 percentage error of B. So it is 2%. Then 1 by 3 percentage error of C. So it is 3%. And 3 times percentage error of D. So it is 4%. It is 4%. So how it is going to be now? So this is going to be 2 plus 1 plus 1 plus 12. Okay, so this is going to be how much? This is going to be 16%, guys. This is going to be 16%. So what is going to be the answer? The answer is 16%. I hope it is fine to everyone. Right? Yeah? Please answer me. Please answer me. The live student can always respond to me, guys. The live student can please respond to me. Okay. So this is how, guys, we are going to get the percentage error. Right? Now let's solve a few more questions here for our better understanding. So here is one more question. Let's try to do this. There is one more question. Let's try to do this. I'm very sure we can do it if we try to. So the live student, they can respond to me in the live chat, and the students who are watching the recording of this session, they can pause the video. They can pause the video here. They can pause the video here, and after pausing the video, you can solve this question first before I solve it. See, error analysis question you will see in abundance when we are seeing the previous year questions. Okay, and also I hope that you are solving the previous year question. Okay, to dimensionalize many previous year questions we have solved. Okay, on this channel, you are going to see the PYQ series. In the PYQ series, there were 2 sessions done till now, and PYQ1, PYQ2. So in those sessions, we have solved questions of dimensional homogeneity, dimensions, units. Okay, okay. So solving previous year question is of utmost importance. Okay, so I'll be solving some more PYQs of NEET examination very soon after we complete this particular error thing. Okay, vernier caliper and screw gauge. So now in the new syllabus update also, vernier caliper and screw gauge is removed from the first unit, but it is there in the 20th unit. Okay, so we have to read vernier caliper and screw gauge. Okay, and that is we are going to cover in this section. Okay, I hope you are updated about the new change of syllabus, right? Okay, we'll talk separately about it. Don't worry. Now, the density of material in the shape of the cube is determined by measuring 3 sides of a cube and its mass. Oh, this is something new information. We always know. What is density? Density is mass per unit volume, right? Now, to get the volume, we must measure the 3 sides of the cube. If the relative error in measuring the mass and length are respectively 1.5% and 3%, what is it? It is 1.5% and 1%, sorry, not 3%, it is 1.5% and 1%. The maximum error in determining the density is. So what is density, sir? Density is mass per unit volume. Density is what? Mass per unit volume. And what is, so this is a cube, na? This is a cube. So can I write the density is equal to mass upon volume. So volume is what? So if I say the side of this, the length of the side of the cube is L. So can I write the volume of the cube as L cube, right? Okay, so it will become ml to the power 3. Now, again using the same funda, can I write delta rho by rho into 100 is equal to delta m by m into 100 plus 3 times delta L by L into 100. Can we write it right away? What do you say? Can we write like this? Please answer me. Yeah. Yes or no? Yes or no, guys? I'll just make some space here. Delta L by L into 100. Okay. So we can write like this. Absolutely, sir. Absolutely no problem at all. So delta rho by rho. What is this delta rho by rho? So delta rho by rho into 100. So that is percentage error in density. Percentage error in density is equal to delta m by m into 100. So what is the relative error in measuring the mass? So sir, it is 1.5% plus this is going to be 3 times of percentage error. Delta L by L is what? So this is percentage error in measuring the length. So this is 1%. So it will become 4.5%. So what is going to be the answer to this question? So the answer is A. Okay. So how we are applying the formula, how we are applying this concept of finding out the error in the measurement of some quantity, I hope that is clear to you guys. I hope that is clear to you guys. Okay. Okay. Now what if it would have been a cuboid? Okay, like that means that L, B, and D are different. What you would have done? So, sir, in that case, what we would have done? So, sir, it will become mass upon volume. So, mass upon volume is LBD. So, if we want to then get the percentage error, what it would be? It will be delta M by M plus delta L by L plus delta B by B plus delta D by D. What is the problem in that? No problem at all, sir. No problem at all. Yeah. Right? Please answer me. Is this fine? Okay. Now let's try one. See, more question we try, more better we are going to feel in this particular topic. So sometimes they give you formulas, sometimes they want you to know the formula beforehand. Okay, right? So some like this question, like the previous question. So you are expected to know all these formulas. Okay, okay. Right now in the question, I'll be writing you the formula because I assume that this is the first chapter of your physics. So many of you might not have been gone through the whole of it, the whole of the formulas of physics. So I'll be providing you with the formulas. No worry. Now please do this question. I'm very, very sure that we can clearly solve this question. Please try it. Please try it. Please try. I'm very sure we can do it. Please do it, guys. Very simple, guys. Very, very simple. Let's try it. Let's try. See, unless you try to solve the question, you are not going to feel better in that. In any particular chapter, you must solve as many as question you get hands on. Right. And while you are watching this video, I'm expecting that you are making your own notes. I'm expecting that you are solving each and everything here. Right. So if error in measurement of radius of sphere is 1%, what will be the error in measurement of volume? Okay. Okay. So what is the volume of the sphere? So it is 4 by 3 pi r cube. Okay. Basically, it is proportional to r cube. Okay. Because see, if you write 4 by 3 pi r cube, there is nothing, no error in 4 by 3 into pi. Okay, there couldn't be any error. It is a part of formula, so it has infinite significant figures. No? So we are sure about 4 by 3 pi. So right away we can do like this. So we know, so the volume is proportional to r cube. So what is going to be the delta V by V into 100? It is going to be 3 times. It is a very simple question. Delta R by R into 100. Okay, delta R by R into 100. So see, this is delta, so this is percentage error in volume. It is equal to 3 times the percentage error, 3 times the percentage error in what? In radius. So 3 times percentage error in radius, so that is going to be 1. So 3 into 1, that is 3%. 3 into 1, that is 3%. So if the error in the measurement of the radius of a sphere is 1%, the error in measurement of volume is going to be 3%. I hope it is fine to everyone. Now moving ahead. Now moving ahead. Okay, let's solve one more question. Okay, so let me think. Okay, so I'll give you one question. Let's suppose that we are having R1. So let us a bit now going to make it a bit more tricky. So R, let's suppose it is 5.0 plus minus 0.2 of ohm. Okay, and R2 is, so ohm is the unit of resistance. So R1 is this, R2 is, let's suppose 10.0 plus 0.15 plus minus 0.15 of ohm. So what is the total resistance? So in the last session, we have seen that if two resistors are connected in series, what is going to be their cumulative error or their net error, or there is what is the final error in the measurement of resistance. So now here, what is the total resistance in parallel? Okay, what is the total resistance in parallel with possible percentage error, right? With possible percentage error. Okay, so in this question, what is required to do? So there are two resistances. One is R1 and one is R2. Now when we have the two resistances here, R1 and R2, we are going to arrange them in parallel. So we already know this. Sir, resistances can be arranged in parallel or it can be arranged in series. Now let's suppose they are arranged in parallel. Now in this case, you are required to find the total resistance, that is sometimes we call it equivalent resistance, right? So you can get me the total or you can get me the equivalent resistance. Okay, also you need to give the possible percentage error. Okay, what is going to be the possible percentage error in that? Please go for it. I'm quite sure we can do it. Now these two are arranged in series. These two, R1 and R2, are arranged in parallel. Okay. Okay. So please do attempt this question. Very, very interesting question. So, sir, in this is going to be 1 by R is equal to 1 by R1 plus 1 by R2. Now, if the students who are following my sessions here, they would be thinking, "Arey sir, how we are going to solve this? You never told us about this. That when some equation like this comes to us, how to solve them? 1 by R is equal to 1 by R1 plus 1 by R2. We know R is equal to R1 plus R2. So are we going to do that in the same way? No, that is not the same thing. This is not similar to this now. This is not similar to this. Is it similar to this? No, sir. This is absolutely not similar to this. Okay. Okay. So how we are going to do it? So we have to use our brain. We have to be a little bit more, a little bit more cautious while solving this question. So how we can solve this question? So first of all, what we are going to do? We are going to just convert it into one way. So can we write it here? R1 plus R2 is equal to upon R1 R2 upon R1 and R2 upon R1 and R2. So this is going to become this is just a moment. So this is going to become 1 by R. Okay, 1 by R. So can I write from here that R is equal to R1 plus R2 upon R1 plus R2, right? R1 plus R2, right? Now please observe this. This is a very, very important thing. Now please understand this. Now please understand this. So this goes like this. Now this goes like this. Now how you can solve this? Now if I say there is one quantity X is equal to A, B by C, how you are going to find the error in X? So sir, you will be writing delta X by X is equal to delta A by A plus delta B by B plus delta C by C. You can write like this, no? You can write like this. Now, in the same way, you can do like this. Now, what you can consider R1 plus R2 as one entity. Okay, let's suppose it is equal to C, one entity. You can consider as one. Okay. Now, if you consider this whole R1 and R2 as one, how you can write this expression for error? So can we write like this? Now please observe. Can we write like this? Now please observe. Same thing I am going to do. Just compare. Here A is R1, B is R2, and C is complete R1 plus R2. Okay, complete R1 plus R2. So can we write like this? Delta R by R into 100. Delta R by R into 100 is equal to delta R1 by R1 into 100. Okay, into 100. Okay, okay, plus delta R2 by R2 into 100, because we are writing in terms of percentage. No, we have to give the answer in percentage. Sometimes you need to give answer in fractional error means. So accordingly you can solve the question. Now can we write this whole entity? So there must be some error cumulatively in R1 plus R2. So delta R1 plus R2 upon R1 plus R2 into 100. See, just what I am doing, I just consider this whole R1 plus R2 thing as C. So delta C is what? Delta C will become delta R1 plus R2. C is R1 plus R2 into 100. This is going to be the expression for you. This is going to be the expression for you, right or wrong? Please answer me. Okay, this is going to be the expression for you guys, right? Right. So how we can do it now? Please observe. Let's read the question. So what is delta R1? Now please understand this. Very very important. Delta R1. So delta R1. So clearly it is zero point 0.2 ohm. Okay. What is delta R2? It is a 0.15 ohm. Okay. 0.15 ohm. Now, what is delta R1 plus R2? Now, if I write what is delta R1 plus R2, sir, it is going to be equal to, so sir, errors in addition and subtractions are always added. Remember the last session? In the last sessions, we have told you this. No? Errors whenever two physical quantities are added or subtracted. They are added or they are subtracted, they are going to have the same, their will be added. Whether it is added or subtracted doesn't matter. Errors are always added in addition and subtraction. Now, when I am going to add these two, what was the rule of addition of errors? So the final error must be rounded up to the same number of decimal places, same number of decimal places, same number of decimal places as in the what? As in the as as equal to the decimal places of least value, least decimal place in the value. So what is going to be? It is going to be, so if I add zero point 0.2 and 0.15, it is going to be equal to 0.35, right? But we want to reduce it to one decimal place. We want to reduce it to one decimal place. So it will become 0.4. What is how it becomes 0.4? Now please observe. So we are rounding off. We are rounding off. So when we are rounding off, this is 5. This is 5, and this is an odd number. So this is 5, this is odd. So this has to be increased, 3 has to be increased to the next number. So how this happens, we don't have any idea. Guys, see, please go to the previous session where we have discussed about the significant figures, the rounding off of the significant figure. Okay, in those sessions, I have explained this very nicely to all of you. Okay, okay. So if you watch those sessions, you are going to know that how we are going to round off to be like this. So what is delta R1 plus R2? So like in this kind of a question, we missed this point. When errors are added, the final, when two significant figures are added, the final solution must be reduced to the value having the minimum decimal place. That means that, so see, there are two values here, two significant figures, 0 0.2, 0 0.15. Okay, when we are adding that, the final solution must have the same number of decimal places as present in the value with least decimal places. Okay, so 0.2 have least decimal places. Huh? So we have to reduce the final answer, we have to reduce the final addition to the to a single decimal digit. So it is going to be equal to 0.4. This is how, so many teachers even miss this thing. Now, what is the delta R1 upon R2? So I'll be putting the values now. So it is 0.2 divided by 5 into 100. Then this is delta R2. So it is 0.15. It is 0.15 upon 10 into 100. And now this delta R1 plus R2, we just have seen, so this is 0.4 divided by R1 plus R2. So it is 15 into 100. It is 15 into 100. So from here, we can make the calculation. From here, we can do the calculation, right? Okay. Okay, sir, how we are going to have that calculated? So I am a teacher, I can use the calculator, right? You don't use the calculator, you do by yourself, right? Okay, so 0.2 by 5 plus 0.15 by 10 plus 0.4 by how much? 15. Okay, okay. So we are getting nearly. We are getting nearly into, I have to multiply it with 100, right? So into just one moment, into 100. So we are getting 8.16%, nearly 8.16%. Okay. So this is going to be the error into it. This is going to be the error into it. Okay. Okay. I hope it is fine to everyone, right? Okay, wonderful. 8.16% is the percentage error. So what is asked in the question? They are asking you what is the total resistance in parallel with possible percentage error. So now what is the total resistance? So this we can find from here now. This we can find from here. So R is equal to R1 plus R2. So here in the formula, now please understand, in the formula we don't have to use the error. We will be using the true value or the mean value of that particular quantity. So it is 5 into 10 upon 5 plus 10. Okay, so 50 upon 15. So it is going to be 3.33, right? It is going to be, so I'll just have to do like this. Just a moment. Huh? So I'll have to put like this 5.0. See, because see, we have to be careful with the significant figures also. There is nothing to be hurried about. 10.0 upon 5.0 plus 10.0. Okay, 10.0. So here two significant figures are multiplied. So it will become 50.0. Okay, it will become 50.0, and this is going to become 15.0. Okay, 15.0. So now when we solve it, we are getting 3.33. In general, we are getting 3.33. But can we write 3.33? No, sir. In multiplication or division, here, in the case of division or multiplication, the final solution must be rounded off to the same number of significant figures as present in the value with minimum significant figure. So see, significant figures are very important aspect, and it is to be taken care while you are dealing with the error analysis. So this is not going to be the answer. This is going to be the 3.3, because we need to round this off to one decimal place to the same number of significant figures as present in the value with the significant figure. Okay. Okay, so we are going to get 3.3. So what shall be the final solution? The final equivalent resistance must be written like this: 3.3 plus minus 3.3 plus minus how much percentage? How much percentage? Plus minus 3%. Sorry, 8.16% of 3.33. So in any case, if you want to give the value, you can have 8.16% of 3.3, and then you can write in the same way as we know, as we learn to write. I hope it is clear to everyone, right? Can we say it is clear to everyone? Yes or no? Right, all the live students and all the students who are watching this session. I hope this is clear to everyone. Okay, now let's do one more question with one more concept. Okay, so now it's a very interesting question, it seems. Okay, so let us try this one. All right, so let's try this one, guys. Very interesting question. Very interesting question. Let's try this one. Let's try this one. So the length of one rod is 2.53 centimeter, and that of the other is 1.2 centimeter. The least count of the measuring instrument is 0.01. So see, with each of the question, I'm trying to give you one new concept. Like in the previous question, some concept we have attained. Like if it is, addition of two quantities in multiplication or division, how to deal into it, how to deal with that. Okay. Similarly, in this question, one more new concept comes up, that is the least count of the measuring instrument. Okay, the least count of the measuring instrument is 0.01 centimeter. Now, what do we mean by the least count? What do we mean by the least count? So, the least count is basically it is the minimum. It is the minimum measurement that can be done from a measuring instrument. So, it is 0.01 centimeter. So, that means it is 1 year caliper. Generally, 1 year caliper has 0.01 centimeter least count. I told you this previously. Now, here we are not interested in whatever device they have measured it, but the least count is 0.01 centimeter. The meaning of least count for in context to a measuring instrument is that you cannot measure accurately any measurement which is less than this. Okay, okay, okay. So if you are going to measure 0.099999, you cannot be able to measure that. And if you change the significant figure, is 0.01. Now, whenever the least count is given to you of any instrument, this is the maximum possible error. This is the maximum possible error. This is what? This is the maximum possible error. Okay. Okay. So least count in any question, if provided that this particular thing has this least count. So we are going to see like the cases of the simple pendulum also. So there is one experiment that we do now. There is one experiment that we do. What experiments do we do? So one experiment that we do is one experiment that we do in our laboratories is finding the G through the pendulum setup, right? Okay, there is questions in which least count of the stopwatch is given. So how to deal with the questions having the least count of the measuring instrument? So this least count is the maximum possible error or the absolute error. Okay, okay. And I already told you least count is the smallest measurement that can be taken from an instrument. So an instrument, whatever maximum possible measurement. Okay, what is the smallest, sorry, not maximum, what is the smallest measurement an equipment can do with accuracy is what we call as the least count. So now please understand it. So the length of one rod is 2.53. Okay, let's make it. So we have one rod, let's say name it AB. So this is having a length of 2.53. So length of AB is going to be how much? It is going to be 2.53. And what is the error into it? So the maximum possible error is 0.01. Okay. Now that of the other, so let's call the other one as CD. So that of the other, that is CD. So length of CD is given to be 1.27 plus 0.01 plus 0.01. Okay. Okay. Now this AB and CD, so they are connected end to end. If the two rods are put end to end, find the combined length. So if we are putting them end to end, that is AB and this is CD. Okay, so I'll write CD here. Okay, so now this is going to be 2.53. So now when we are putting them end to end, so basically what is the final length? So it is going to be L1 plus L2, right? Okay. Now delta L is also going to be delta L1 plus delta L2 because in addition and subtraction both. Okay. Now if it would have said that the lengths are subtracted, they are placed one over the other. So what is the remaining length left? Okay. So in that case, you must be subtracting, but the errors there are also added. Okay, it is not like when you are subtracting the errors, subtracting the quantities, their errors are also subtracted. Errors are always added, remember, in both addition and subtraction. So when we do like this, so L is equal to L1 plus L2. So delta L will become delta L1 plus delta L2. So this is going to become how much? So 1.27 plus 2.53. So in, when we are doing the addition of two physical quantities, we simply do the same addition. So 2.53 plus 1.27, this is going to become how much? So 3.80. No problem, sir, 3.80. And what is the error? So it is 0.01 plus 0.01, that become 0.02 centimeters. So what is ultimately the L? L we must write like this: 3.8 plus minus 0.0. 3.8 plus minus 0.0. Right? Okay, I hope it is clear to everyone. Now please understand this. Now let's say this L1 and L2 are to be subtracted. Now if this L1 and L2, if this L1 and L2 are to be subtracted, so it's 2.53 minus 1.27. So if they need to be subtracted, so I can write L is equal to 2.53 minus 1.27. Okay, 1.27. So what it would be? 2.53 minus 1.27. So we can have it calculated now. So we all can do it. Right. Right. So 2.53 minus 1.27. So it is going to be 1.26. Right? 1.26. So what is the final length we must write? Sir, it is 1.26 plus minus again 0.02 centimeter, because whether it is addition, whether it is subtraction, in both of these cases, in both of these cases, errors are always added. So even though if these two quantities are added or subtracted, their errors are going to get added. And whenever in a question least count is provided for any particular measurement, that least count is nothing but the absolute error in that measurement, or the maximum possible error in that measurement. Okay, you got the figure, sir? How come, sir? But sir, we have heard least count, so 0.01 can be measured accurately. Okay, okay, 0.01 can be measured accurately. Okay, this is someone at one class, offline class, our student told me. So how could 0.01 be the error? Least count is the smallest measurement our equipment can do. Now please understand this. So you believe 0.01 can measure accurately. I also believe in that. I agree to it 100%. But do you agree to me to this? Sir, 0.0099999. It cannot be measured accurately. It cannot be measured accurately. If this is your measurement, if you want to measure this from this particular instrument, you are going to get the error. So this could be the maximum possible error. Okay. Okay. Now, if you round this off, you are going to get 0.01 only. Now. So that is why the maximum possible error we have written here 0.01 centimeter, because you need to round this off to two significant figures, right? Sorry, one significant figure. How many significant figures are there? Sir, only one significant figure is there. Okay. Okay, so when you are rounding off, you are getting the same thing. So there is no need of any confusion. So let's do one more question. Let us try to solve one more question. Okay. So here we go. I hope you are getting interested. See, more questions we are solving, more better we are going to be in the physics. See, physics is the kind of subject in which questions has no limit. Okay, you need to solve question as much as you can do. Okay, you need to solve as much as you could, because see, more question you solve, more things you are going to observe, more things you are going to see, more approaches you are going to learn, more concepts you are going to learn. So this way only you can and you must proceed for your NEET examination. Okay, now let's try this question. This is one of the previous year questions. Okay, so in this section I'll try to explain this error analysis thing in the form of questions. Okay, in the form of questions. Please do that. Please do this question. Okay, so how we can do this question? Okay, let's read the question first. So in a simple pendulum experiment, so I was speaking, this is quite a famous question. This is asked in NEET examination, IIT, JEE examination. Although our target is NEET examination, but sometimes the questions relative, so similar questions get asked. Okay. Now, in a simple pendulum experiment for determination of acceleration due to gravity, time taken for 20 oscillations is measured by using a watch of 1 second least count. Now, please listen to me very, very carefully. In a simple pendulum experiment for determination of acceleration due to gravity, acceleration due to gravity. So the simple pendulum experiment you might have done in your 11th laboratory. Okay. Okay. So here the time taken for 20 oscillation is measured by using a watch of 1 second least count. Okay. Now please understand. Okay, let's first read the question. The mean value of time taken comes out to be 30 seconds. Okay, we'll have to understand what is given here. The length of the pendulum is measured by using a meter scale of least count 1 mm, and the value obtained is 55.0 centimeter. The percentage error in determination of G is close to. Now please understand this. If you don't know the formula here, the question is over. In the examination, the question is over. You cannot attempt this question. But sir, from where we are going to know this formula? So as I said, in units and measures, this is one of such chapter which almost uses the equation, the formulas of every chapter. Okay, more or less every chapter. And these formulas we are going to see later. So if you haven't seen this formula till now in your preparation, in your study, don't worry at all. You are going to have a comprehensive understanding of it, but you have to wait for the right time for that. Now, in a simple pendulum, so what is the formula of time period? So when you see the formula of time period, it is going to be 2 pi root over L by G. 2 pi root over L by G. Now, first of all, let me make this formula because I have to determine the G now. So whatever is to be determined, let's take it to the left hand side. So if I square this equation, it will become T square is equal to 4 pi square, and this has become L by G. So G is going to be equal to 4 times pi square upon L by T square. This is going to become the formula of G. Okay. Now, if I apply my concept, so this 4 pi square has nothing to do. There is nothing, no error in this. This is the part of formula. When something is part of formula, it has infinite significant figure. It doesn't have any scope of error. So 4 pi square, we have nothing to do with it. Okay. Now, can we write this delta G by G into 100? Okay, or let's write delta G by G for time being, because we have to percentage error we have to get. Okay, let's first write delta G by G. We can later multiply 100, or we can right away multiply 100. Doesn't matter. Right away we'll do. Don't worry. Okay, into 100, it is going to be equal to delta L by L plus 2 times delta T by 2 times delta T by T. Now please understand this concept. Now first of all, so what is this delta L by L? Now the pendulum, the length of the pendulum is measured using a meter scale of least count 1 mm. So delta L is 1 mm, but this is given in centimeter. So don't forget to convert it into centimeter. Okay, so this is 0.1 centimeter. Okay, so we have the delta L, no problem. So we have this delta L, 0.1. Okay, I forgot to multiply 100. Here also we have to multiply 100. So the 0.1 upon what is the length? The length is 55. So 0.1 upon 55 into 100. Now the question is, what I am going to do for this delta T by T. Now let's understand what is the delta T and T. Now T is the time period. Let's understand this first. Okay. Please understand, very, very useful. T is the time period of one oscillation. Okay. When you are going to see this chapter, okay, you are going to see that T is the time period of one single oscillation. Okay. Okay. And so what is the delta T? What is the delta T? Okay. So delta T, it is the error. It is the error. It is the error in the measurement of T. It is the error in the measurement of this T. So this is going to be the error in the measurement of T. So see, in the question what is given. Now see how this is different from what is given in the question. So the time taken for 20 oscillation, not one oscillation. the time taken for 20 oscillations, by using a watch of 1 second least count, the mean value of time taken comes out to be 30 seconds. So what does it say? It says that for 30, someone has measured the time taken for 30 oscillation, not one oscillation. The T we are having in our formula is the time taken in one oscillation, not 30 oscillation, right? Okay. So now please understand, and this is the least count of the watt. So basically, this is the maximum error in measuring this time, right? Okay. Now please understand this. Now here, what is given in the question? Now I'll just make something out of it. Now, if let's suppose if small t, let's take one, is time taken, or I'll say like this. So time taken for an oscillation, So if the time taken for an oscillation is, let's suppose, t, okay. So what is going to be the time taken for one oscillation? So obviously it is going to be t by n. So can we write the capital T is equal to t by n? Okay, capital T is equal to t by n, right? Okay. Okay, so what is going to be the delta t? Delta t is going to be delta t by n, because n is the constant, no? N is the constant. Right? N is the constant, right? Okay. Okay. N is the constant. So when n is the constant, guys, when n is the constant, we are going to have it like this. Okay, we are going to have it like this. Okay, so delta t is nothing but equal to delta t by n. It is going to be equal to delta t by n. So from here, can I write? So now from this equation, t is equal to t by n. Now let's consider this as a formula. Now can I say that delta t is equal to t by n? So using the differentiation part, can we write it like this also? Delta t by t is equal to small delta t by t. Okay. Okay. So now instead of delta t by t, can I replace it with a small delta t by t into 100? Are you getting this thing or not? Okay. Okay. Now see, in this formula, this capital delta t upon t is the error in measurement of one oscillation, and t is the time of measurement of one oscillation. But we can replace this ratio with the error in measurement of some n oscillation to the time taken for the n oscillation. And how we are doing it, I just shown you. Okay. Okay, so simple mathematics. If time taken for n oscillation is a small t, that means the time taken for one oscillation is t. So the time period is t by n. So from here, can we write delta t by t is equal to small delta t by t, just using the same principle of errors, right? Okay. So now when we are doing it, so now we can write it straight away. No need of thinking anymore. So delta t is what? So delta t is 1 second. Okay, because this is the time taken for measuring 20 oscillation. And what is the time in 20 oscillation? It is 30 seconds. So this is going to be equal to 100 into 100. So what is going to be the percentage error here? Delta g by g into 100. So when we are solving it, it is going to become 1.181, and this is going to become 6.66. Okay. So cumulatively, it is going to become 6.84% nearly. So delta g by g into 100, that is percentage error in the measurement of gravity, is going to be equal to 6.8%. Okay. Okay. I hope it is clear to everyone. Okay. So now many students get confused here. So don't worry about it. I just proved you that the error in measurement of one oscillation to the time taken for one oscillation is equal to error in measurement of n oscillation, error in the measurement of time of n oscillation, and the time for that n oscillation, right? Okay, so we must know the concept also, because in somewhat tricky questions we are needing to use it. Okay, so guys, in this session, what we have done, we have understood the error analysis by means of some very interesting questions. So I'll be coming up with some more questions on this, but in the previous year question or important question session series. For context point of thing, this is what I wanted to tell you in the error analysis. And see, solving questions has no limits. There are many questions out there. You can go and solve it, and you can tell me in the comments that this question we are able to make and this question we are not able to make with what you have taught us. Okay, so guys, we are going to keep it to this point in this session. Thank you very much. Have a good day, and please don't forget to subscribe the channel, your only channel, your very own channel, NEET Success Simplified. Okay, so hope to see you in the next session. Thank you very much. Have a good day, and we'll see you in the next session.